So think about this for a second. Your car, your air conditioner, even your phone charger, they all pull power from a grid that was designed for a completely different century. We have physically electrified our world, but our digital systems of kind of haven't kept up with this whole changing ecosystem. And that's a problem because the energy grid of the future isn't just about the physical infrastructure, it's also about, it's more about the data coordination and trust. Now, we are in the middle of one of the biggest energy transformations in history. We are kind of seeing major forces which are kind of converging: decentralization, decarbonization, and digitalization. On one hand, we are seeing a huge surge in demand, whereas on the other hand, our supply is kind of a very distributed and stochastic. There has been some extraordinary progress, but we are still trying to integrate billions of intelligent assets such as EVs, batteries, heat pumps, wristbands, etc. So through this presentation, I want to show you two concrete examples of how this broken digital infrastructure is kind of actively holding back the energy transition. So the first example is of a EV charging energy and coordination crisis. Now, so since we're speaking about the UK market, so I want to give you the current scenario, right? So over 40, there are about 45,000 public charging points in the UK right now, which are operated by dozens of networks like BB1, Spotpoint, InstaVolt, INET, and many others. Now, when driver they need three or four different apps to be the same thing, right? Which is find, book, or pay for a charge. On the operator side, every new integration is bespoke, a patchwork of APIs, billing systems, and backend workflows. So the real world impact for users is so people are getting more anxious about charging locations. They are not confident about public charging. The adoption takes time, and it is becoming weaker and weaker day by day. Each charging network operates as a very walled garden, and there's no digital shared infrastructure which is equivalent to a mobile phone roaming or HTTPS or similar internet protocols. So, through the digital energy grid, the idea is to it would enable a digital infrastructure that kind of enables these platforms to seamlessly discover, authenticate, charge, and transact at any location while participating in grid services. Moving on to example two, it's a demand flexibility crisis. So the current scenario is the UK is targeting around 600,000 installations every year by 2028, and this number is going to increase further. So, so with this, we will see a lot more installation of smart meters, rooftop solar and batteries, electric vehicles, smart appliances, and thermostats. So this is leading to a digital fragmentation kind of a problem. So any users heat pump is kind of managed by one app, with one protocol. The EV charger speaks another language on some another protocol. So everything is kind of very digitally fragmented. Right? Uh, Through digital energy grid, we kind of see all these broken pieces kind of come together.
So if you see in all the examples of what we have shared, there are three missing pieces in the puzzle. First one being the no universal identity. The second one being the no machine readable interoperability. And third one the no cryptography traceability. So I will explain in a bit. I mean, I'll explain this all this. What does it mean? So then you know universal identity. So if you see today the energy asset, the participant, and the transaction layer, a global, unique, verifiable digital identities. It is like trying to run the internet without IP addresses or the phone systems without the phone numbers. The second one, so if you see the main machine readable interoperability. So currently what happens that data exists in proprietary systems. So system can automatically discover, read or understand or act on the information from other systems, which requires a manual reconciliation and increasing cost and creating the delays. Then third one, the low cryptography verifiability. It means that there is no temper proof way to establish the trust. Who generates the data, who consumes the data, and when. And this forces reliance on the expensive intermediaries and the manual audits. And these are the missing pieces of the puzzle is solved by the DEG. And that is why the whole idea of the DEG started. So DEG is not another application or platform or proprietary system. It's a vision for an open interoperable digital infrastructure built on three foundational principles. So what are those three foundational principles? Let us understand those three. First is the universal identity. Second is the machine readable data. And third one is the cryptographic verifiability. So what do we mean by the universal identity? So every energy asset participant in a transaction get a unique verifiable digital identity like a phone number for the energy system. So your EV or heat pump or battery. So all will get a recognizable ID. Now, what do we mean by the machine readable data? So it's like open standard the data formats that allow all the systems or rather any system to discover, read, understand, and act on the information from any other system. So technical specification, real-time generation, consumption data, all in standardized and machine-readable format. Now, the third, what we mean by the cryptographic verifiability. So it means the temporary records that establish trust without expensive intermediaries. Every transaction, generation event, consumption pattern, and technical claim is cryptographically verifiable for all the parties. So these are the three building blocks of the DEG. Earlier, what we have shown, there are three missing pieces, and all the examples we have shared. So these three missing pieces will be solved by these three building blocks of the DEG. So as we saw earlier, the EV charging process today is completely broken. In order to get access to all chargers in a locality, a user would have to download and juggle between multiple apps. This is inconvenient and often ends up leading to users not using the best chargers to them. With DEG, however, we are able to solve this problem. DEG allows users to access any charging station through a single app. Each buyer app connects the user to every listing from every single seller app. This enables the users to always choose the best charger available and the best price. All payments, etc., take place seamlessly through the same buyer. With DEG, the current broken and siloed EV ecosystem becomes an open, interoperable, and verifiable network. In terms of demand flexibility, again, we saw how the current scenario comprises a very inefficient, broken down system where every piece of the puzzle speaks a different language. Integration of different devices takes duplicated effort in a very long time. With DAG, every device has unique, verified digital identity and machine readable data. This means a grid operator or a utility does not need to integrate devices separately. They can instantly discover and connect thousands of devices through their respective digital identities through the foundation layer that is DAG. Now the grid has a lot more to fall back on when it requires flexibility. Any SO estimates that demand flexibility and its potential could save the UK £10 billion annually by 2050. DG helps bring that goal closer to reality. In the UK and DG Cambridge area, we have two problem statements in the hackathon. I'll just briefly give you a brief about how the problem statements are or what the context and challenges are. In a further documentation and the further orientation call, you will be able to go through the minimum expected capabilities and good to have capabilities as well. So the problem statement one, as you can see on the screen, is the utility interface with agentic orchestration for grid scale demand flexibility. So the context is utilities are increasingly unable to autonomously monitor and mitigate feeder level spikes in real time as distributed energy resources proliferate behind the meter. Manual coordination is slow, expensive, and lacks visibility and traceability. So the challenge here is to build an agent that acts as a reliable co-pilot with a command-centered dashboard interface for the DSOs. This DSO could be something like the UK power network, right? Which can forecast and manage local load flexibility at feeder and substation levels aligned with object flexibility reforms. Moving on to the range level two. As AI and digital infrastructure scale exponentially, something fascinating is happening.
Computing and energy are starting to converge. Data centers today are no longer passive consumers of electricity, they are dynamic, intelligent nodes in the energy ecosystem. They can shift workloads, store power, and even provide flexibility back to the grid. But our systems aren't built for that yet. Compute and energy operate in silos. The grid doesn't know when any workloads spike, and data centers do not know when renewable generation takes. The result is inefficiency and wasted potential. The challenge ahead is to build an agentic orchestration system that optimizes compute demand and energy distribution in real time. Imagine AI agents deciding when to run workloads, when to defog, and when to support the grid, creating a truly intelligent, sustainable, and symbiotic energy ecosystem. That's the future of compute energy governance convergence in a digital energy world. Thank you.